Good day, good day, good day, good day, good day, good day, good day. Welcome to YeboTutor Livestream Help. I hope you guys are good. Let's prepare for our test, which we are writing tomorrow, our exam from paper 2 for physical sciences. Let's prepare it so that we can see if we can engage on that and prepare it properly. If it's your first time, please don't forget to do the right thing and subscribe. And of course, do yourself a favor and join through the description of this video and join our WhatsApp group so that can be able to be assisted anytime, anywhere, and in real time. Without wasting much time, let's go over the paper which was written last year as our mock so that we can prepare for tomorrow. As you can see, this is chemistry 150 marks. Then all this, your questions and your your instructions and all that stuff. So starting now from the question, the first question now, let's get down to the work. So we can see that from the questions which were given, we can see this is for the paper 2. Now we can see that the homologous series that contain a carbon triple bond is called, this is easy guys, we know that that's our alkanes because it has these triple bonds between the two different carbon atoms. So this is quite straightforward. That's our alkanes. Now consider the following compounds. First one, we are given pentyl, one, or these are all alcohols. Then C is a carboxylic acid, as you can see. Which one of the following correct rank the above pure substances in the order of increasing strength of intermolecular forces? Of course, we know that we start with this one. Okay, then we go again with this pentyl. Then of course the last one will be this one. So our answer will be on D, because when we are looking at the intermolecular forces, we know that we have the London forces, we have the dipole forces, and we have the hydrogen bonds. So we need to check that out and use that so that you can be able to rank. So they start from the London forces, they're going from the dipole to the hydrogen bonds. That's how strong they can be. 1.3, consider the structural formula which we are given here, which is given as the follows. Which one of the following compounds contains the above functional group? Of course, this is your 1.3, and we know definitely this is an aldehyde, okay, which is definitely our proper now, okay, because definitely this is an alcohol. There's no way this will be an alcohol. This is a ketone. This, we're no way that will be a ketone. This is a carboxylic acid. There's also no way that can be a carboxylic acid. 1.4, we are given 2-methylpropane 1-O can form 2 isomers. What are isomers? Okay, we know that we have our positional isomers, we have structural isomers. Which one of the following combinations correctly identifies the isomer and the type of isomer? Okay, so definitely if we are given 2-methylpropane 1,0-O, we can see that we can get a positional isomer there, which will be 2-methylpropyl. So you can see that it was initially on 1. Now we just have positioned it and changed it, so it's now on 2. So correct answer there will be on D. Now the conversion of this CH3CHCH2 to CH3CH2CH3 is known as what? So this is our 1.5, and definitely this can never be hydration. This should be our hydrogenation. How do we see that? You can draw these structural so that you can see that it's CH3 1 2 3. Then of course we have another C there which has 1H. Then we have another C there, then another C has 2H there. So in order for everything to be full, this has to have 4, so that will be 1 2, which means that can be like that. Then this one only have 1H there, so that will be 1 2, so which means we can have again 1 2 1 2 3 4, something like this. Then you can be able to have that. So you can draw this, so you'll be able to see that, oh man, if you can be able to name this, then that will be able to assist you, and you'll be able to see that that will give us hydrogenation all over there, and that will be our proper correct answer over there. Now moving forward to the next part which we have here, so we can see that we have the following question 1.6, which is saying hydrochloric acid reacts with excess zinc according to the balanced equation. As you can see, 2HL, which is hydrochloric acid, with zinc, and of course we can see that will produce that. Now, which one of the following factors influence the yield of H2, which is the hydrogen gas, but not the rate of the production? Definitely what will influence there on our 1.6 is just easy, guys. We know that will be the volume of the hydrochloride, so that we can see how much it can be able to influence that. So that will be that. Then 1.7, carbon Carbonic acid H2CO3 ionizes in water in two steps. The first step of ionization is given by this equation, which we can see here. Okay, then from that, which one of the following substances in the above reaction can act as an ampholyte? Oh my word, ampholyte, which means it can act as both a acid and base. So definitely we can see that our answer is not going to be easy there. Of course, we know that water always can act as an ampholyte because it can be an acid, it can also be an base. And of course, also HC03 can also be part of that as well. So that will be our ampholyte. So what is important is to understand the definition. What do they mean when they speak about the term ampholyte? That will be very crucial and very, very important in the process. All right. Going forward, we can see something here which we didn't think about, but this will play a big role for us when we are solving this question which we have here. Okay, so the potential energy diagram of the for the following reversible hypothetical reaction is given as follows, as we can see. Now the question says that consider the following statement regarding the energy diagrams. So the first one, the change in H enthalpy for the forward direction is positive. The catalyst will be lower, PQ. And of course, we can see that the reversible reaction is exothermic. Which statements above is or are true on 1.8? Definitely, guys, we can see something which is very easy, guys. Here we can see that our answer here definitely will be that this is for the forward direction. That's true. And also the reversible reaction is exothermic, as you can see. All right, that's quite straightforward. So answer here will be on C. All right, now going forward, we can now proceed to 1.9. So consider the following reversible reaction at equilibrium. Underline that part. As we can see, this is what we have, and you can see these two arrows are representing that this reaction is reversible. The volume inside the container is decreased while the temperature remains constant. Now the following question after we saw that is that which one of the following combinations are correct regarding the amount of CO, which is our carbon monoxide, and the rate at which the new equilibrium is reached. So this is easy, guys, because we can see that the amount of CO in this instance will be lower, and of course the reaction rate will be higher. All right. Now consider the two solutions which were given, Ba and also the other one, potassium. Each concentration have that to be 0.1 mole per decimeter cubed. Consider the following statement regarding the two solution. So we can see that both the potassium KOH plus Ba that can be regarded as Arrhenius, yes, bases. Others can say on number 2 that will produce higher concentration of the OH ion than the KOH, okay, as it dissociates. Then also the double the amount of HCl is needed to neutralize that. So definitely the question or the answer which will be true there, definitely we can see that both this and this can be able to be regarded as these two bases, and also we can literally just see that this will produce this BaO2 will be able to produce higher concentration of the OH ion than the KOH when it dissociates. All right, so that was not bad. So those are the 20 marks. Please try to make sure that you get those easy straightforward questions, because that will give you more marks on that. Now let's proceed to the next question which we have here, which is going to be now question 2. Now let's solve problems. Now I'm tired of doing easy stuff, so please make sure that when you're writing tomorrow, go through your stuff, then you'll be able to understand what's really going on. Okay, now define, let's read the first question first. So we're given the table below shows organic molecules A to E, as you can see, A to E, with different homologous series. Definitely they'll ask you what is or define homologous series. Okay, so we can see this is our A, we see our B, C, E, and all that. Now the first question, define the homologous series. Guys, this is easy. We know what is a homologous series. We know that a homologous series, it is a series of organic compounds, okay, that can be described by the same general formula. Easy stuff. You get your 2 marks, guys. showing you how to do things when you're writing the test. Write down the letter that represents the following compounds. A hydrocarbon. Guys, we know what is a hydrocarbon. Let's check. So we can see that this is a hydrocarbon. As you can see, this is an alkane. Alkene. As you can see here, this is a hydrocarbon. It only have a double bond there. So that's an alkene. So a hydrocarbon is a B. A haloalkane. Definitely that should be this one, because we can see of this Cl which we have, that will bring and give us a haloalkane there. An alkene, that will also be on B. As I said, we can see that because of this double bond, so that will give us a alkene as well, because an alkene is also a hydrocarbon, guys. Okay, the compound that contains the carbonyl group that is bonded to two saturated carbon atoms. Carbonyl group, let's check. Carbonyl group, we have that aldehyde, we have the ketone. So our answer will be on C, because you can see butane 1, which is a ketone over there. So this now is in this carbonyl group and is bonded to two saturated carbon atoms. All right, so that's not bad. That's almost straightforward, so that everyone can see that and can be able to maneuver from that. Is compound D a primary, secondary, or tertiary alcohol? Give a reason for your answer. Let's see D. Here is D. We can see we have all the and that. Of course, we can see that our D, there's no way it's gonna be primary. It's a secondary alcohol. Why? Because we can see that the carbon atom, the carbon that contains the hydroxyl group, okay, is bonded to two carbon atoms. So when I say the hydroxyl group, I mean the OH, okay. As you can see, this OH is bonded to two carbon atoms, so there's no way it can be primary. Primary is supposed to be 1, but since they are 2, which means this will be a secondary one. All right, now going forward, write down the general formula for the homologous series to which compound B belongs. To compound B, we say that's an alkene, so the general formula there, it's not even hard at all, because we know that this is CnH2H2N. That will be our general formula there for an alkene. So that is CnH2N. Now, do an IUPAC name of compound B. Let's go for compound. Hey, they love this compound B. So we know that this is an alkene, and we also know that this is a hydrocarbon. Now they want us to have the name for that. Let's look for our biggest chain. That's 1, 2, 3, 4, 5. So we can see that we have 5. That will be our parent chain, because we're counting close to that double angle. So which means that's a pent, right? So we know that we have that, and we can see that we have that double on position 2 there. So that will be pent 2, and of course in, right? That's that part. Then now we can see that we have a number 4. Yes, so it's 1, 2, 3, 4, 8, 4. We can see that we have our chain there. So we can see that at 4 we can have 4 methyl pent that. Okay, that's easy. So the first thing was to check what is our parent chain. So we can see that we have 5. That's our longest chain, which is 5, which is pent. So we now have to check where is the double bond. We can see that it's on position number 2. So that's pent 2 in. Then now we can see that we have that long base there, which is going to be on number 3. So if you can't see the way you can also draw this, all right, and you have a structural formula, which is going to be like, you'll see 1, 2, 3, you'll see 1, 2, 1, 2, C, H, another one, C, then also this one, you draw them as well, and also this one, you can also have their structural formula, so that can be able to assist you. Okay, so that's one is easy. As we say that will be at 4 methyl. That's where we see where we have that other one, and the parent is on the pent, which is on position number 2 of A. Great. IUPAC name of compound D. IUPAC name for compound D. Let's see what would be the IUPAC for compound D. Compound D. Let's check that out. Compound D is here, and we say that this is a secondary alcohol. As you can see, this is the position in which it is at. We can see we have that chain over there. We also have another chain here. We have another chain here. So this will be easier, right? So if we are counting this properly, we can see that this will be on position 1, 2, 3. So that's where we have the on position 3. So that's 1, 2, 3, 4, 5, 6. So we have 6 over there. So since we have 6, that's a hexane, okay? And you can see that the alcohol, the OH there, is on position number 3. So that will be 0.3 on. All right. But now we still have those extended things. We can still see that we have the other chain there. We can see we have 1 there by, so this is 1, 2, 3, 4. So we have 1 there by 5, 5. Okay, so because there are 2, so it's 1, 2, 3, 4, 5. So in this position 5 we have this and this one. So now that will be 5, 5 dimethyl. Okay, because they are both 2 and there are those 2 chains there. So we can now have that. So that would be at 5, 5 and it's at that dimethyl. And of course we know that this is for the hexane because it's 6, the parent is 6, and the OH is on position number 3. So that is not bad. Now compound C as a functional isomer. Where is compound C? Okay, we can see the compound C, which is a ketone. It is a functional isomer. Now the question will be define the term functional isomer. Guys, we know this, guys. So we know that these are compounds that have same molecular formula. Okay, formula, but they have different functional groups. The fact that it's a functional isomer, which means it's only the functional group which is the different, but they have the same molecular formula. Now draw the structural formula of the functional isomer of compounds. Guys, this is easy, guys, super easy. So definitely we can see it's butane, which means it's 1, 2, 3, 4, which is 4. So we can now have our different 4s, 1, 2, 3, 4, right? And of course we know that that can give us a functional isomer, which is like this. Then we have our H over there, we have our H over there, H over there, and of course that will give us something which we all know and which will be oh beautiful. Okay, yes, here we go. So that will be 1, 2, 3, 4. Then of course we have that O over there, C over there, then we have our H there. So that will be our structural formula for the functional isomer of compound C. Right, going forward, 2.6, compound E, which we are given here, is CXHYO2 reacts with alcohol P, which means definitely this is a carboxylic acid. Definitely. By now you should know this, because when you're writing tomorrow you shouldn't panic at all, because you already know what's happening. In the presence of the concentrated sulfuric acid, my word, definitely this is esterification. To produce organic compound Q, as shown by the incomplete equation below. Guys, this is just obvious, guys. Definitely we know that this is esterification for the fact that they are using that concentrated sulfuric acid. Now they say that the percentage composition of compound Q will be, for carbon we can see that's that 58.82%, then for hydrogen 9.81, oxygen for that. Okay, the molar mass of the compound Q is equal to the formula mass. All right, write down the name of the type of reaction that is definitely, guys, as I said, this is esterification, because you can see that we are reacting carboxylic acid as well as alcohol in the presence of the concentrated sulfuric acid. So this is esterification. Now determine by calculation the molecular mass of the organic compound Q. That's nice. We can do this using our empirical formula. Let's see if we can create something over there for us to work with. Okay, so for this question it's easy, because we know what we are doing. We are given carbon, we know that the carbon has 12, and hydrogen it's 1, oxygen it's 16 over there. So our life already has been easy because we know what's going on over there. So this is easy, guys. So we know that if we can have our carbon over there, and that will be let's decrease that to 10. Great. Then that will be, we can have our carbon is 2, our hydrogen is 2, our oxygen, of course, we are given that 58,1,82. We divide that by 12. Okay, then for hydrogen that will be 9,81 divided by 1 over there. Then another one will be 31,37 divided by 16 over there, as the same way we were doing for the empirical formula, guys. Please don't forget how we apply this, because it's quite important and very, very crucial. Okay, so please never forget that part, because it's very, very important, and you need to know how to apply that as well. So now this will just give you what, 4,90, 9,81, then divide that by 16, that will be 1,96. Then of course, what do? We divide by the smallest one. In this instance, it's 1,96. We divide all through by 1,96 so that you can get that formula they want there. So now that will be 1, then there that will be 5, of course, then 4,9 divided by 1,96, that will be 2,5. All right, so if we now have to make our life easier, that can just be, so that we can remove that comma there, that will be 5 over 2, right? So to remove that comma there, that will just be 5 is to 10 is to 2, so that we remove, because this one is 2,5, so 2,5 is equivalent to 5 over 2. So to remove that, we just multiply all through by 2 by 2. So 5 times 2, it's 10. 1 times 2, it's that. So now we can see that by the empirical formula, our empirical formula, grade 11 work. Now our empirical formula will be C5H10 oxygen 2 over there. Then for the molecular formula, then, as they have asked, that will be C5H10O2. So what is very important in this question is to understand that we are dealing with this part that we need to solve and get the molecular formula using our empirical formula. Okay, so since we are already given in terms of percentages, and we know that 12 is the molecular formula for carbon, other one is 1, other one is 16, then we just do the right thing. We divide those percentages, then we get our ratios, then we need to simplify them, and we divide all through by the smallest one. Then after that, since we got 2,5, we know 2,5 is the same as 5 over 2, so we multiplied all through by 2. Then we ended up having our empirical formula to be C5H10O2. Then our molecular formula as well will be C5H10O2. Great, that's 5 marks. Wow, it's worth it. Now compound E, which is CXHYO2, is a molecular mass of this 74 grams per mole. Okay, determine the compound E. What is compound E? And write down its IUPAC name. Guys, this is already easy because we know what is our empirical formula, so our life already is now getting more easier and easier, right? So we can solve it in 2 different ways because you're already given what we have over there. So that can be our molecular mass for our CXHY or 2 over there, which is equal to 74, right? So we know that this can be 12N because the molecular mass, the molecular what for C, it's 12. Then we also have our 2N over there plus 2, of course, you're already given that 16 is equal to 74. Then we can calculate our N over there. That will be 14N is equal to 74 minus 32. Then of course, when we divide all through by 14, divide all through by 14, then we get our N to be equal to 3. So definitely we can see that if, since it's 3, which means that IUPAC name 3 is for propane, right? So since it's a carboxylic acid, that will be propanoic acid. Easy stuff. So that's how we solve it, and that's how we get to the answer. Because bottom line, we know this, we know carbon, we know hydrogen, we know oxygen. So now we just put N there where we don't know how much we are multiplying with. Then of course, after that, we can be able to get our N value, which is 3, which means that this will be our propanoic acid. All right, if there's any question, please don't hesitate to drop your question in the WhatsApp group. Don't hesitate to drop your question in the comment section so that we can align and help each other and solve the problems together, because when we are together we can get far. All right, Now going forward, now let's see if we can solve the next following question. So we are given, determine the organic compound Q that was produced, write down its IUPAC name and structural formula. 6 marks. Oh my word. Let's check that out, please. So they want us to see what was this compound which was formed, okay? So when we react the carboxylic acid as well as the alcohol, what do we get? That's the first question which we need to understand, okay? So that will give us that ester, okay? Because that's one thing we know for sure. Okay, we know that when we have a propanoic acid, as we can see, propanoic acid, we add that plus alcohol, of course, under the concentrated sulfuric acid, that should give us an ester, okay? And this ester, we add that plus our H2O. So this is already easy for us, all right? So we know that our life is already easy because we already know what we are working with and what we are playing around with, all right? So for this one, for the ester which we are having over there, since we don't know what's happening for the alcohol, we can calculate that for the alcohol, M for the alcohol, that will just be equal to your 102 minus 18 minus 74, then we get that to be 46, sorry. That will be 46 grams per mole for the alcohol. Easy stuff, because we are looking at this P alcohol P. So that's how we now go for that. Then from that point now, we know that definitely this will give us an ethanol. All right, so our alcohol will be an ethanol, because that will be just 46 divided by 2 there, 23. So that will be so our final formula now, we can see that our ester will be ethanol, okay? Don't forget that. Sorry, let's go back in here, open that. Yes, that will be ethyl propanoate. Okay, that's 2 propanoate. Easy stuff. Now we can draw this now easily, because that's ethyl 1 2. So H H H H H. Then we have our carbon, then of course our oxygen, then of course our 3 C's, since we say that's propanoate. So that would be our ethyl propanoate. So now you have your 34 marks just to be able to solve this and getting your answer. So please don't forget and go and mind yourself. What do we do when we are doing this process, or when things are going through this esterification process? How do we solve that? It's very crucial and very important. Please go and mind yourself on that question. Great. Now let's proceed. 34 marks in the pocket, 20 plus 34, we are getting there. In this paper, we have okay, we have 7 questions. Okay, we are already done with question number 3. Now we're going to question number 4, and at least we are still in an hour period. So let's proceed. Let's cook. Let him cook now. Let him cook. Now question number 4. Consider the flow diagram showing all the organic reactions given below. We can see that reaction 1, reaction 2, reaction 3. Consider reaction 1. Now, name of the type of the elimination on reaction number 1. We can see that's that elimination, going to that. So we can see that for the first one, that elimination, guys, what will be the elimination? Did I skip something? Let me see. Oh, yes, I skipped this question 3. Sorry, guys. Now, an investigation is carried out to determine the effect of branching on the boiling points of an organic compounds. 3 primary alcohols that each contains 5 carbon atoms are used during this investigation. Equal volumes of each alcohol are heated separately in a water bath. All of them, they are heated separately. Now, from that point, now we can see that's our alcohol 1, alcohol 2, alcohol 3. Define the boiling point. Oh my word, we know that boiling point, it is the temperature at which the vapor pressure a liquid, others will say substance, is equal the atmospheric pressure. As always, guys, don't forget that. Please never forget that. All right, that's the boiling point. So tomorrow they might ask you the melting point, or they ask you to define vapor pressure. Please don't forget those definitions. Those are the two few marks which you can get. What property of alcohols requires them to be heated in a water bath? Of course, they are so much flammable, guys. We know that they are so flammable. So that's why. So you can just say alcohol are flammable. Okay, don't worry about that. They are all flammable. That's why they have to be heated in a water bath. Write down the boiling point of alcohol 1. Alcohol 1 is here. The boiling point is here. This is 150, so it's around 140 degrees. So you're just reading your graph over there. All right. Is this a fair investigation? Right? Only yes, no. Give a reason. Let's see. Alcohol 1, alcohol 2, alcohol 3. They all have the same things. Is this they all have 5 carbon atoms? Yes, definitely, yes, definitely. This is a fair investigation, if you still remember, because now when we're speaking about isomers, we say that we have positional isomers, functional isomers, which means this makes it more sense because they all have the same carbon atoms. They all have 5 carbon atoms, but definitely they are different in terms of their orientation. Maybe others are positional isomers and all that stuff. So we can say that yes, definitely this is a fair investigation, because we know that compounds have the same molecular mass. Okay, or others, they can say compounds are, as I said, they are isomers. Okay, are isomers. They can just have the same carbon atoms, same molecular formula, but they have different positional and the functional and all that stuff. Give the IUPAC name of alcohol 2. IUPAC name for alcohol 2. Let's check. Alcohol 2. Okay, that's not bad. So that can be our 2-methyl butan 1. Oh, right. That's not bad. So that can be our IUPAC name for alcohol 2. We can see that butane, there are 5, but of course we have 2 there. So you can just name it as you can see it for our alcohol over there. As you can see, even here, they say that 3 primary alcohols. They are all primary alcohols. So there's no way that shouldn't be hard for you to just give that. Okay. Which alcohol has the shortest chain length? Definitely, guys, we can see that's alcohol number 3. Because the larger the surface area, the higher the boiling point. So definitely, since the boiling point of alcohol number 3 is low, definitely that will have the shortest length. Now, write down only alcohol 1, alcohol 2. Definitely is going to be alcohol 3. Fully explain your answer. Guys, this is easy, guys. We know that the chain length decreases, right? The chain length decreases from 1 to 3, as you can see, alcohol 1 to alcohol 3. So what does this mean? Which means there will be a decrease in the strength. Okay, when we're looking at our IMF, the intermolecular forces. Okay, then of course of these London forces. Okay, or you can say your induced type of forces in this, from what? From alcohol 1 to 3. Then of course we can relate the strength of London forces, and we can say that the energy will be involved. So this is quite easy, guys. As you can see, that's how we always explain. Please don't forget how to explain, as this will come as well to your test when you are writing tomorrow. 3.8, a second investigation is carried out to determine the effect of intermolecular forces on the vapor pressure. So we can see that we have those two now. Define the vapor pressure. See, these definitions are going to be asked tomorrow. Please don't forget these definitions, guys. They are very, very crucial. They are very, very important. All right. So we can see that there on 3.8.1, what is the vapor pressure? We know that this is the pressure. It is the pressure exerted by a vapor at equilibrium with its liquid in a closed system. That will be your vapor pressure. Now, explain the difference in vapor pressure by referring to the intermolecular forces involved. Guys, this is quite straightforward, guys. The same question which you're answering above, the same one which you need to answer again here, but in a different approach, okay? So we can literally see that this butane 0O, which is the alcohol, we can see that it has hydrogen bonds. So from that point now, our life is already easy for us. So we can say that this one is the hydrogen bonds, okay? Then this other one, the butanone, which is the ketone, this one is the dipole. First, let me write it here down for you. So we can see that the butane, 1-ol, this one has hydrogen bonds. Then the other one, it's butane, the ketone. This one is dipole. Dipole forces. You're already on 2 marks over there. So what does this mean? This means that hydrogen bonds are stronger than the dipole forces. What does this mean? That which means stronger intermolecular forces IMF result in lower vapor pressure. Makes a lot of sense, right? Because this is what we know. As you can see, that other one is small vapor pressure, other one is, and also we know that this one with the smaller vapor pressure is the one which is the highest boiling point. So those are the things, guys. That's how you explain over. You check 2 of them, you compare both of them, then you see which one will give you the proper and the correct answer. Now, will the vapor pressure of the above compounds increase, decrease, or remain the same at a higher temperature? Definitely, guys, it will increase. This is just straightforward. It will definitely have to increase. Now, question 4, we can see that we are given this question, which is quite a beautiful question. Consider the flow diagram showing organic reactions given below. We can see that's alcohol, reaction 1, reaction 2, reaction 3, and reaction 2 and reaction 3. Now let's look at reaction 1. Where is reaction 1? This is reaction 1 from here to here, okay? Write down the name of the elimination reaction. So from alcohol to having that compound P and water, guys, this is straightforward, guys. This is our dehydration, for the fact that we are producing water there, which means we are dehydrating it, okay? So that's dehydration. Name or formula of the inorganic reagent needed. Definitely for that will need us to have our H2SO4, which we all know as our sulfuric acid. So we usually and always use that sulfuric acid as our inorganic reagent that will be able to assist us to eliminate using this dehydration method, so that can be able to produce a compound B, P, and water as well. Balanced equation using structural formula for the organic compounds. Write down the balanced equation using the structural formula for the organic compounds. That's not bad, because we can see that we are given that, so we can start with that one, then we can be able to draw the other one as quick as possible. All right, so that would be our how many C's do we have there? We have 1, 2, 3, then we have that OH 4, so that will be 4, so that's not bad. So that will be 1, 2, 3, 4. Then of course on the third one we had that O, and we had that OH over there. Then of course that will make our lives already easier. All right, on the third one. Then on the fourth one we have that, so that's already having our lives easier, of course. Then we can have that, then we have that. Okay, as you can see here, that's the structural formula. Yes, let me see. That'll be 1, 2, 3, 4. Yes, on the third, that's where we have the OH, as you can see here. Then that will be that. Then this now produces what? It produces this specific alkene. Don't forget this, an alkene is produced during this process, okay? So that will be 1, 2, 3, 4 as well. But now it will now produce an alkene over there. All right, so that our lives can be easy. Now that's your age, that's your age. So always, guys, go and revise that. And dehydration process, it undergoes this elimination, and it produces this compound, which is an alkene, as well as this is all going through in the presence of the reagent, which is the sulfuric acid. Please don't forget this. All right, and this will produce this alkene, and of course plus water over there. All right, 1 2 3 4. Okay, that's the fourth one. Then double H, 1 2 3 4, 1 2 3 and 4. Then of course plus our water, H2O. Okay, plus our H2O, which is the water. Okay, H2O, that would be our water over there. Great, that will be our answer for 4.1.3. Now let's look at reaction number 2. Now that we know this is an alkene which is produced over there plus water, now reaction number 2 is producing this. So now definitely we now need to understand, write down the name of the reaction that is taking place. Definitely this is going to be our reaction for that part. This reaction is taking place, and this reaction's name is, either you can just say it's addition reaction, or you can now be specific and say this is hydrogenation, halogenation. Hello, because of that Br which we have here. All right, now the second question proceeds, and the second question says structural formula and IUPAC name of the major product formed. For that reaction 2, that's not bad, guys. We know that it's going to form our bromobutane, right? So that will be, it's going to form our, let's see, 1 2. So our, on the previous one which we had here, we had our alkene on position number 2. Yes, so which means we're gonna have that bromo here. So we're gonna have our 2 bromobutane. All right, so now we can just do that. So we have 1 2 3 4, and position number 2 we have that Br over there, so that we can remove that double bond which we had from the alkene over there. Guys, organic chemistry is beautiful. This is where your 50 marks is coming from, guys. Please make sure that we revise this. Now, because the reaction number 3, okay, now we have this is reaction number 3, from the alcohol to this product which we have there. Now write down the 2 reaction conditions that are needed, guys. Definitely the first one, for this process to go properly, we need mild heat, right? The number 2, of course, we need a dilute strong base. Those are the 2 things which are needed there, and they are very, very important and very, very vital. Now let's look at 4.2. Octane can be cracked according to this incomplete equation. Why is it incomplete? Oh, we have Y there, which means we need to know what's the Y in the process. Now, the 2 straight chain organic compounds C4Hy and C4Hz are now passed through bromine water Br2 acquisition at room temperature in a darkened room. The following observations are made. When compound C4Hy is bubbled through the bromine water, no changes are observed. Oh, okay. Then on experiment 2, when there is that, then we can see that when compound C4Hz is bubbled through the bromine water, the yellowish color of the bromine water immediately turns colorless. All right, and bubbles are observed in the flask. Okay. Let them cook now. Let's see, and let's see if we can solve that as quick as possible. Now the first question is define cracking. Guys, you know what is cracking? I can tell you what is cracking by now. We know that cracking, it is when we are breaking down or the breaking down of long chains, right? Long chain, let's say long chain hydrocarbons molecules into more useful shorter chains. As easy as that. Then you can define your cracking. Now, give a reason why experiment 1 and 2 are carried out in a different room. Guys, definitely they have to be carried out in 2 different rooms, because we know that we want to minimize the ultraviolet, which is the UV light present, so that we can have other one in the dark, other one in the presence of light. Okay, other one here you can say that no substitution reaction can occur in a saturated hydrocarbon, one of those two. Which compound C4Hy and C4Hz is unsaturated? Definitely it's C4 it's C4Hz. That's definitely, guys. Why? Because we can see that it readily reacts with the bromine, okay, without the presence of the UV light. So definitely that's why, as you can see here, it's literally able to react with the bromine, which we have here, without the presence of that UV light. All right, compound C4Hy undergoes the following reactions, as you can see there. Now, write down the structural formula of the compound C4Hz. Let's see. 2 marks. Structural formula for C4Hz. 1, 2, 3, 4. Okay, HZ. All right. So that would be just 1, 2, 3, 4. Yes. Then of course we can have our double bond there. We have 1 with that, 1, 2, 3, 4. Then of course we have our normal 4 bonds over there. So that will be the structural formula. Now, combustion reaction of compound C4Hy using molecular formula, guys. Come on. This is going to be so easy, guys, for us to have that combustion, because we know that will be C4H10 plus O2. Then this should produce CO2, our carbon dioxide there, plus our water there. So now we have to balance that, right? So we can see here we have 2 oxygen, then this side we have 3 oxygens, we have 10 hydrogens, this side we have 2 hydrogens, we have 4 carbon, this other side we have 1. So if we can have this, now this will be 2C4H10, which means now we have 8 carbons, this other side we have 2, so which means here we need to also have 8 carbons, right? Now we have 16 oxygen, the other side we have 2 oxygen, so now that will be 16, is it? Yes, 16 plus that 1. So here we now have to accommodate that hydrogen there. They have 10, they now have 20. This other side they have 2 on the other side, so which means we can make that up. Then now we can now see that we now have 16 over there, then we have 2 10, then that will give us that. Then if we can also have 13 over there, then now our equation is balanced. All right, so we write it initially as it is, then after that we balance our equation. That's your organic chemistry over there. Then you are happy and you get your marks. Guys, ask me questions. Why are people not asking me questions on the charts? Ask me questions over there, or join the WhatsApp group immediately as I'm speaking. If you're not on the WhatsApp group, and text your question, I'll be able to see your question from the WhatsApp group right now. Then we can be able to interact from the WhatsApp group. So you can type here, or you can type on the WhatsApp group, which is in the description of this video, so that you can be able to connect with us anytime, anywhere, and in real time as well. Question 5. At least we are almost done, guys. As I wanted it not to be long, let's proceed to question number 5. A group of learners used the reaction between magnesium carbonate and excess hydrochloric acid, as you can see, to investigate some of the factors that affect the reaction rate, the balanced equation. So this equation is literally balanced, as we are told. The learners use this apparatus, as you can see, the gas syringe, the gas, the magnesium carbon, which we are also told here as well, carbonate, and also the hydrogen hydrochloric acid. All right, the table below summarizes the reaction, which you can see the experiment 1, 2, and 3. We can see the concentration is remaining the same. The state of that is powder lumps, and the initial temperatures, they are also different. Now define the term reaction rate. What is a reaction rate, guys? This is where you need to get those marks, guys. We know that reaction rate, it is the change in concentration of reactant, okay, or product per unit time. Okay, now going forward, write down the independent variable of the comparison between experiment 1 and experiment 2. Everything is the same. Definitely we can see that temperature is changing over there, so definitely we can see that the independent is temperature. Why? Because we can see that for these two, everything, the concentration is the same, the state of division is the same, but the temperature is not the same, which means that's the independent variable which we have. So that will be temperature. Experiment 2 and experiment 3, as we can see here, now compared. So when we compare experiment 2 and 3, which we can see here, I already see they have the same concentration, but this is not the same. The temperature is the same. Okay, which experiment 2 or 3 will have the highest reaction rate? Definitely, guys, we can see that our experiment 2 will have highest rate. Okay, now they say explain that with referring to the collision theory. Guys, we know that the experiment 2, guys, will have the highest. Why? Because we can see that it will have more particles exposed to the larger surface area, right? So you can just write that as well. You can see that experiment 2. Why are we saying that? According to this collision theory, we know that experiment 2 has more particles, okay, exposed, or larger surface. Okay, then what does this mean? Which means that they have more particles that will collide with correct area or orientation, the space they are working in. That means that more effective collisions per unit time. So that will be just that, and you get your correct answer over there. All right, that's all straightforward, guys. Please make sure that you remember that. That's how you explain using this collision theory. Or someone will say that, okay, in experiment 3 there are less particles which are exposed, as you can see. So since there are less particles which are exposed, now we can say that there will be less particles which will be able to collide with the correct area or orientation. Therefore, that will lead to us have less effective collision. So you can either do for the positive, or you can do the opposite one, so that you can get the proper answer over there. The learners measured the rate at which carbon dioxide was produced in experiment 2 and found it to be this. Okay, it took this minutes to measure the time taken for the reaction. Calculate the mass of MgCO3 that was used for 6 marks. Oh my word, stoichiometry now has to play a big part. I hate this. I hate these questions. I'm sure someone also listening here also hate these questions. But of course, because I'm a good person and you also are good people, let's see if we can solve this and get the correct answer. All right. So we can now look at the rate first, maybe. And we know that that will be our change in mass over the change in temperature. Okay. So we can have our 0.25 there. That will be our rate as they told us, right? Yes, 0.25 there. That will be equal to our initial mass, which we want to calculate, minus initially it was 0. Then, of course, we divide by our time which it took, which is 10.44, right? Then we get that we cross multiply over there. So that will be m is equal to 0.25 multiplied by 10.44. Then using our calculator, I am getting mine to be 2.61 grams. And from that point, we know something, that number of moles is always equal to the mass over the molar mass, right? That's what we know. So now we can be able to solve that quickly and possible, because we know how to get that. So definitely we can now calculate the number of moles. This will now be equal to 2.61 divided by the molar mass, which is going to be 44. Let's check something out here. CO2, that will be 12 plus 32, because 16 plus 16 is 32, that will now be 4, 4. So that's where the molar mass is coming from, because we are looking at the molar mass of CO2, right? So the molar mass of that CO2 will be 44. Why? Because carbon is 12, oxygen is 2 times 16. And that's how the 44 is coming from, guys. Please don't be confused. Then I'm using my calculator right now, and I'm getting my answer to be the number of moles, which is 0.0593. Okay, that will be my number of moles. So and say put moles there. Now let's do the ratio. Now let's see our balanced equation. Okay, we can see that it's 1. Now the question wants us to calculate the mass of MgCO3. Where is MgCO3? So we can see that is going to be 1:1 according to the ratio there. So this means that the number of moles of CO2 is also equal to the number of moles of MgCO3. All right, so that will also be equal to 0.0593 moles. Why? Because we used the stoichiometry and we did the ratio and we balance. This is 1 and also this one is 1. So that's where that number of moles is equal to each other because of that. So now that we know the number of moles, then now definitely we can now calculate the mass, because we know that N is equal to the mass over the molar mass. But now we are looking at the molar mass of MgCO3. So now we can now see the mass will be equal to the number of moles multiplied by the molar mass of MgCO3, and our number of moles is 0.0593. Then you multiply that by the molar mass Mg, it's 24 plus 12. That's 36. Then 36 plus 16 times 3, that's 48. So that will be 48 plus 36. 48 plus 36, that's 184. Yes, so that will be 4. Don't try this at home, please use your calculator. Okay, so we know that this will be our 24 plus 12 plus 3 multiplied by 16, then you get your 80. For me, I did it by my head. You use your calculator. We can't do this, we can't try this at home, we have to pass. All right, so now we can multiply this 2, then we can get our answer there. So when I'm multiplying here on my calculator here, I am getting 4,9812 grams. So that will be the mass of MgCO3. Now the following question: calculate the molar volume of CO2 in 1,47 decimeter cubed of CO2, which was released. Guys, this is now boring. The moment they say molar volume, we know that number of moles is always equal to the volume over the volume, Vm. All right, so we are told that this is the molar volume, Vm. So now we can now be able to calculate the molar volume, which they want, which is the Vm. All right, so we already know N, we know Vm. So now we can now calculate V, because V now is equal to number of moles multiplied by Vm. And our N in this instance is going to be that 0.05. We have calculated it. Where is it yet? 0.0593 multiplied by that. Wait, are they multiplying each other? No. So that will be that Vm. We are calculating Vm. So we have already been given V. So Vm now will be equal to V over N, which is now equal to that 1,47 divided by 0.0593. Oh my word, please don't forget this equation, guys. This is when we are using it STP, or maybe when they tell you that they need the molar volume. Okay, so usually this is 22,4 at STP. That's the equation which you use to calculate the number of moles, but in this instance we're using it to calculate the molar volume. Then without wasting much time, this will just be easy, and my Vm is 24,79 decimeter cubed. All right, the graph below represents Maxwell-Boltzmann distribution curve for the CO2 produced in experiment number 1. Now that we know that, redraw the graph in the answer book. Clearly label the curve as A. On the same set of X, sketch the curve that will be obtained for CO2 if the mass of MgCO3 used increase. Label this equation as big. Okay, guys, we can make this our A, because there's nothing much that will change, but the B one can be a bit different. That will be something like, so that will be your B, guys. Okay, that will be your A, that will be your B. Then you are done with that. Question number 6. All right, Then we go to question number 7. All right, great. Let's see if we can run through question number 6 over there so that we can proceed and finish this as quick as possible. Don't forget to subscribe if it's your first time. Don't forget to text us on WhatsApp, on our WhatsApp group. Don't forget to join the WhatsApp group, which is in the description of this video. If you have any question, please don't hesitate to ask your question, because we are here to help you. Now, initially 1 mole of sulfur dioxide SO2G and oxygen O2 are allowed to react in a sealed container according to the balanced equation, which we are seeing. This equation is balanced, and we can see that these arrows are like this, which means this is a reversible reaction. The graph below shows the change in amounts of reactants and products over time, and bear in mind that this graph, definitely they will never draw this to scale. All right, now 6.1.1 state the Le Chatelier's principle in words. Definitely we know that when the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that will oppose the disturbance. All right, that's easy. Let me repeat that. I don't want to write that, it's quite long. So we're saying the Le Chatelier's principle states that when the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that will oppose or that will cancel the disturbance. Now, 6.1.2. How will the rate of forward reaction compare to the rate of the reverse reaction between T1 and T2? Choose higher than, lower than, equal to, and give a reason to your answer. Let's check that T1 and T2. Here it is. Now we need to check between the forward and the reverse reaction. T1, T2 forward, then the reverse is like that. Oh, okay, definitely we can see that they are equal to, guys. We can see that as well, that they will be equal to. And what's the reason? Because we can see that the chemical equilibrium is reached. That's why they are equal to. As you can also see that the forward and the reverse, they are literally equal to each other. There you can see that at T1 and T2. Why? Because the forward and the reverse, the chemical equilibrium has been reached. Which curve X or Y represent SO2? Give a reason for your answer. X, Y, definitely CO2. Let's check CO2. Okay, definitely your Y will represent your SO2. Give a reason for that answer. Hi, but guys, we can see that 2 more of SO2 will react with 1 more of O2, guys. That's so easy, guys. Okay, so that will be able to assist us, and we'll get answer for that one. Someone can also say that the rate at which SO2 is consumed is twice that of O2, as you can see from here. 6.1.4. Now, the temperature of the reaction mixture was decreased at T2. Okay. Now, is the heat of the reaction positive or negative for the forward reaction? Yebo. It's negative. How can it be positive when it's been decreased? Explain the answer by referring to the Le Chatelier's principles. Oh my word. We know that one thing which is very sure, it's negative because the amount of the concentration of this CO3 increased. Okay, so we can see that. Let me write this down because this is a good explanation people need to have. So we can say that the amount, or we can say the concentration of CO3 increased. Okay, so when this one increased, what happens? You can also say that instead of saying this, you can also say that SO2 and our O2, they decreased. Okay, the amount of concentration of these two, they decreased, or you can just say the other one increased. Okay, so what does this mean? According to the Le Chatelier's principle, LCP, we know that a decrease in temperature favors the exothermic reaction, which means the forward reaction was favored. Dango means thank you. Easy and straightforward, just like that. Then you get your correct answer as well. Now, the temperature of the reaction mixture was decreased at that. Now, let's look at 6.2. let's do serious stuff. We now want to do KC calculations. Oh my word, the easy one. Right. The 2.5 mole of NOCl was initially placed in a 1.5 decimeter sealed of at 400 degrees. After the equilibrium was established, it was found that 28% of the NOCl dissociated according to the balanced equation which we are given here. Now the question calculate the equilibrium constant, or KC. Guys, this is easy because we know how to maneuver around this. Okay, so we can see that we have our 2NOCl, we have our 2NO, we also have our Cl2. Right, so now we need to have our table. Then we know that we are gonna have our initial mole, we can have our change in mole, then we can have our equilibrium mole, then we can now finally have our concentration. Please don't forget, this will be our table: initial mole, change in mole, equilibrium mole, then at the end you have our concentration. All right, so now let's do this and let's solve our question. Okay, so initially we can say that something is very beautiful there. And how can we get the beauty of something there? We are given 2.5 mole was initially placed, which means initially we have 2.5 moles which was placed initially, and of course there's nothing at the output, right? As always, right? Now the change in mole, now we need to see what happened in the change of mole and also the equilibrium mole. So they also told that it was initially placed in that 1.5 and sealed in that, and at equilibrium this is what we have. So this is already easy, guys. Our life has already been made easy because now we can now be able to calculate the change, okay, in the number of moles of the NOCl, which will now be equal to that 2.5 moles multiplied by 28 over 100, as they said here that it was found that 28% of the dissociated according to the to this balanced equation, so that we can see what is the change in number of moles. So that will be 28 over 100 times 2.5. Then here's my with my calculator, then I'm getting 0.7. Right, so our change in number of moles is 0.7. Of course this is also going to be 0.7, but this one now will be 0.35 because now we're going to do more ratio, so it's going to be 2:1. So that's why this one is 2, which is 0.7. This one now will be x, so we cross multiply over there, so that will be 0.7 divided by 2. That's how we got that 0.35 over there. That's the change in number of moles. Then now 2.5 initial mole minus the change of mole, that will be 1.8. let's see, 15 minus 7 is 8, yes. So it's going to be 1.8, then definitely this is going to be 0.7, then definitely this is still just going to be 0.35. All right, then for the concentration, now we know the number of moles. That's easy because that now will be 1.8 divided by your 1.5, and that will be your 0.7 divided by 1.5. Of course, the other one will be 0.35 divided by 1.5 because we are dividing these values which we have here. This is what's the most important part. These two are the most important part. Let's use the other color to be black. We know the change in moles. We also know the equilibrium number of moles. Then now we can now calculate our Kc value. Okay, so Kc will be equal to our NO squared Cl2 all divided by NOCl and it's squared, right? So now that will be equal to 0.47 squared multiplied by 0.23 squared. This is equal to 0.23. This is equal to 0.47. This will be equal to 1.2, guys. Sorry. Yes, 1.2. Please use your calculators. Mine, I'm using it at a faster pace because I want us to finish in time. I don't want this to be a long session. I want you guys to go over the work and revise the work as well. So this will be divided by that squared. That will be divided by 1.2 or squared. As you can see, all of them, they were guesses, so there's nothing we need to remove over there. So now when we do that, now my answer is 0.035. Of course, that will be over there, and you can be able to get our answer for that Kc value, and our life will be easy after that. Now write down increases, decreases, or remains the same only if we say that the more or Cl is added to the equilibrium mixture, how will this change or affect this? Oh guys, this is easy, because we know something from back in the days that this will remain the same, because only temperature can affect the value of the equilibrium constant. Okay, so this will remain the same. Okay, so that question need to be remain the same. Why? Because only temperature affect the value of the Kc, which is the equilibrium constant. Question number 7, which is the last question, guys. Please, again, don't forget to subscribe, don't forget to like, don't forget to comment, don't forget to join the WhatsApp group so that you can be helped and assisted. The balanced equation below represents the first step of the ionization reaction of the sulfuric acid, which is H2SO4, as you can see. Define an acid according to the Arrhenius theorem. Guys, an acid produces the hydrogen ions. Okay, guys, from back then, okay, we know that grade 11 acid, it produces hydrogen ions, which are the OH ions. Okay, or you can just say H plus or the H30 plus, or you can just say hydrogen ions, or these are not hydrogen, these are hydrolium ions in aqueous, as you can see, aqueous solutions. Now write down the formula of the two bases in the above reaction. Definitely water, because it can act as a base in an acid, and of course definitely our HSO4. Now balance the chemical equation for the reaction between sulfuric acid and the potassium hydroxide. Okay, that's a base there, so that would be our H2SO4 plus our KOH. That should produce our K2SO4 plus our H2 water. Then we balance this can be 2, and we can balance this can also be 2. Then it's now balanced in both sides. So now we can see these are our reactants. We have reacted sulfuric acid with the potassium hydroxide. Then after that, it will produce that. Then we also have that. Then we can now balance the equation. Now, a standard solution of sodium hydroxide is prepared by dissolving 3,812 grams to make 100 centimeter cube. Definitely need to change that to decimeter cube. Calculate the concentration of sodium hydroxide NaOH solution. So how do we calculate this? This is easy, guys, because we know that we have the formula C is always equal to the mass over the molar mass times the volume. All right, so we already been given the mass over there, so that will just be equal to 3,812 divided by the molar mass of NaOH. Na, that will be not bad, that will be 23 plus 16 plus 1. Is it 23 or 24? Not sure anymore, but like, let's check it on our Na. Yes, it's 23, so it's 23 plus 1 plus 16 for the O. Then that will give us 40 there. So that's correct. So 40 multiplied by the volume. Our volume is given as 100 centimeter cube. So in order for us to get this, we need to change that to decimeter cube. So we divide that by 1,000. That will be 0,1. That will be our concentration. So now using my calculator over here, I'm getting my concentration to be 0,953 mole per decimeter cubed. That will be my concentration over there. 7.2.2. This is the balanced equation, which you can see now. Calculate the percentage mass of the ethanoic acid found in the vinegar, household vinegar of that mass. Oh my word, this is going to be a long, boring question, guys. But because I'm a good person, let's just solve this, guys. Okay, so let's check first for this NaOH. All right, that will be fast and possible, because at least we can be able to calculate that quickly and get our answer now that we already know the concentration of that. Okay, so we can know that N is always equal to C over C. C is always equal to N over V, which means that N is equal to CV. All right, so this is the n of NaOH, so that would be equal to 0.953 multiplied by the volume, which we know that it's which is given as 21.8 decimeter cubed, centimeter cubed, which means you need to convert that, so that would be 21.8 times 10 to the power negative 3, or someone can just say divided by 1000 there, so that it can be converted back. So let me use my calculator over there. Then I'm getting 0.020775 moles. Okay, now that you have the number of moles, then now we can now see that the number of moles of this and this, they are literally equal to each other. It's 1:1. So this means that the number of moles of NaOH is also the same as the number of moles of CH3COOH, which is just equal to 0.020775. Then from that point now we can now be able to calculate our concentration for the other one, because now we already know and we already been given the volume there to be 25 centimeter cubed. So now we can now calculate using the same equation. So that will now be concentration is equal to N over V. Our N is 0.20775 divided by our volume, which is 25 converted, that will be divided by 1000. Convert that to decimeter cubed, and that will be divided by 1000 there. Then concentration will now be equal to, let's see, the calculator over here, and of course we are getting 0.831016. Of course this will be more per decimeter cubed. Okay, now we have the number of moles. What the question one? Calculate the percentage mass. Okay, now that we have that, now we can now calculate the percentage, or we can now calculate the mass. Now that will be step number 2. I'm trying to find space now. Let's write it here. Let's just use a different marker. So writing it here, that will now just be, we know that C is equal to M over MV, all right? Then which means the mass which we want will now just be equal to CMV. So that will now just be equal to our 0.83, which you've calculated over there. 0.83 1016 multiplied by the molar mass of CH33, that will be 12 3 12 32, and plus the last one 32, so that will be multiplied by 60. Then we multiply by the volume, which is 25, of course, times 10 to the power negative 3 converted to decimal cubed. Then our concentration over the mass, the mass now will just be equal to our 1.2465 grams. Right, now from that point now we can now be able to calculate the percentage of the mass. So the percentage we now be equal to 1.2465 divided by our initial 125. Then we multiply that by 100. And of course our percentage over there will just be equal to 4.986%. all right. Wow, that was a long question. I hate this. I hate this. I hate this. I hate this. Then you get your answer. Then of course now you have your 150 marks. Just imagine we solved 150 marks in an hour 20 minutes. Guys, please do the same thing also when you're writing tomorrow. Make sure that you understand the question properly and you analyze the way we were analyzing, so that you can be helped when you are writing. From me to you guys, have a beautiful evening. If you still have your question, to ask your question in the group, to ask your question on the chat section. I will check it out and we can be able to engage. From me, all the best. From YeboTutor, all the best as you're writing tomorrow. Don't forget to apply in the universities which you want to go and study in next year. Thank you so much, Dango means. Thank you.